Hi, good afternoon, everyone. Hope I'm good audible to each one of you. And my screen is visible. Just confirm whether the screen is visible or not. And am I audible to all of you? Thank you. Thank you for confirming, Madhuri, Vishwa. Okay, so for the previous of session, if you have any of a query, you can ask me. In the meantime, your friends are joining in. We will be starting the session in next 5 minutes. In the meantime, you can ask me any questions you have, any doubt you have. From the last of the session also, you may talk to me. Or last day we had a discussion on the internship. Regarding that also, you can talk to me, anything. You can raise your hands also. I'll allow you to talk. Yes, you're allowed to talk, Molu Guru. You can open your mic and ask if you have any doubt. I'm allowed to talk.
Hello.
Good afternoon.
Good afternoon, sir. Am I audible?
Yeah, you're audible.
Sir, actually, recently I've shared a form in group, right? Google form.
Okay.
We have already filled it when you have shared it first in the group. So we have to fill it again, or is it not necessary filling it once?
If you have filled it once, it is not necessary to fill it again.
Okay.
The participants who have already filled up the form once, many of them are filling again and again. It is not necessary. It is only one time filling is. Few of participants, yeah. Anything else?
Yeah, after filling it one time, we have received the response in our mail as well. So there is no need of filling it again, right?
No, not at
all. Okay. Thank you, sir.
Tomorrow we will publish the list of the registered candidates and what your selections are. And if you want to change, like if many of you have selected the AGEV, still if you want to select some of your UAVs, you can change. That's what the flexibility we will provide till tomorrow. So after publishing, you can see that what all the records you have filled up. And if you need any correction or if you need any kind of a change, you can change till tomorrow. After that, the separate sessions will be going on for the UAV and AGEV separately. So morning sessions will be on the technology part, electronics related technology part, and evening from tomorrow onwards, we will be working on the computer vision, machine learning, Python things, because AI is very heavily used in the autonomous vehicles, whether it is your surface-based vehicles or it is your UAVs. So that's why the computer vision thing, machine learning thing also necessary to be learned. Python, I think all of you have learned in your third year, this semester only. How many of us are here good in Python? One is good in Python? Me, good. Girish is good in Python. What about us? We have 21 attendees now. I'm not going to take a test. I'm just asking. We will be giving the Python classes also. Third semester, okay. Python basics you have learned. So tomorrow onwards, there will be session on Python also at 3 o'clock. Initially, we will be giving you the knowledge on the basics of the Python in 1 to 2 days. Then we will be covering you towards the file handling, the specific of libraries for the computer vision, machine learning, all these things. And then we will be designing the projects basically, like real-time traffic analysis project, if you are doing any kind of a vehicle-based project, there the real-time traffic analysis is required. You need to detect the lanes. You need to detect the foreign objects. You need to detect the distance, like you are making a drone, or maybe you are making a autonomous car. That time you need to detect that at what distance your object is, so that you can take the corrective actions against of it. So since there are two ways, one is to use the sensors, another is to use the vision computing. So we are going to do both of the things. We are going to use the LiDAR-based sensors also, and we are going to use the vision computing also, so that both the methods will be useful for the designing any kind of an autonomous drive. Good. Okay, anyone else is having a question? I will be starting the session now. Still people are joining in. Are you liking the sessions? Did you find the morning session useful? Respond, guys. Okay, Ibrahim liked the session. Anyone can put here any project idea if you have in mind related to the autonomous. Giving 2 minutes. I'll be starting at 3:10. Just in 2 minutes, if anyone can put any idea he wants to make it as a project in autonomous vehicle domain. As a project, we are open to take your ideas. First, we love that if you give the ideas to make your projects. Minutes we have. Anyone? Or not everyone actually. Can give some ideas. There are many of domains. It is not only the construction of the vehicle. It could be the automotive control. It could be the communication. It could be the antenna design. It could be the LiDAR system design. It could be ranging of vehicle. Anything. Just now it is 3:10. No idea came. Okay. So I'm starting the session. By that time, you will mature through the sessions, through the knowledge. Definitely the ideas will come, which you will take up as a major project. So I welcome to all of you in the session. My screen is visible to all of you. So in this session, we are going to talk about the AGEVs, the autonomous ground electric vehicle surface based vehicles, what are the things that has been used in the AGEVs? Why do we require AGEV? Why the focus is not towards AGEV? What are the expectations you can have from the AGEV? And what is the growth potential, the technologies and the growth potential? But before going into this, I would like to share you something, which is the data from the Ministry of Road and Transport. This data says we have a various modes of the transportations, whether it is the road, rail, aviation, that's what the civil aviation we call for the passenger aircrafts. We have the coastal shippings, we have inland water, and we have the transportations through the inland water, like the transportation through the rivers. So there are the these are the different modes we have of the transportation. And amongst all, 89% of the share is of roads only. So this is a huge number we have. And anything related to the road, the autonomous AGEV, which we are talking about, the surface vehicle, which we are talking about, it has the major of a inputs towards the road side only. So it will be mostly working on the roads only. So that's what the, if surface based vehicles we are talking about, that will be moving on the roads, it is having the 89% of the share into the complete of the transportation domain. That is for the passenger traffic ways. If I'm talking about the freights, the movement of the goods, it takes care of 62% of the traffic by the roads. So this is a huge chunk. That's what is being shared through the roads. And that's why it is a very important for us that any of a transport mode, any of the vehicle, any of the automotive which we are thinking of, to be carried over the road, whether it is the passenger based or it is the freight based, there should be providing the ease of the driving, it should be providing to the safety, and it should be the energy efficient also, because if there is a higher amount of energy is being utilized in these, it will be a loss to the economy of the nation. So increase in the share of high value and low volume of commodities, increase in passenger traffic intensity, and demand of a quality transport, that is the necessary thing which leads to the economical development. If there is a 10% increase in travel speed happens, the labor market expands by 15% and productivity by 3%. This is a ratio that has been shared. It is a common thing that if you are traveling to any of a place faster, so definitely the more reach will happen. Like in Hyderabad also, if you can see, earlier, like there are the areas which were not reachable so easily from point A to point B. So the companies were not there. Now the companies are in the far places also, because there is a faster road transports are there. So you can go to any of the places where the roads are good. So labor can reach over there. It is not only the unskilled labor. I'm talking about the skilled labor also. You can go to offices and anywhere very easily. So 10% increase in the travel speed leads to the expansion of the labor market by 15%. And that's how the productivity also increases by 3%. And this road transport covers approximately the 3% of the rupees 2000 billion of a total GDP. So that's again a good number. Also, there is one more significant thing that has been seen, that this good road transport leads to the good of a participation rate in schools education. It increases by 100% for girls and 33% for boys. Due to the safety issues and bad road transport, many of the places the girls won't go to school. But if the good of availability is there, it is an increase being seen by 100%. So this is the significance of the road transport is, and we are talking about the technologies which is related to the roads only, whether it is the autonomous surface-based vehicle drive which we are talking about, it is more towards the roads only. One more thing, so this is the data which I have seen related to the significance of the road transport, and there are the certain of issues also. The first one issue is related to the energy. Once we are using the vehicles, so vehicles are a good source of energy consumption. They consume the energy, whether it is your oil or it is the gas or it is your now electric. So they consume the energy by any of a means, and they will emit the carbon dioxide, CO2. So CO2 emissions of road transport sector is approximately 206.4 million tons, which is 92% of total emissions of transport sector. If just you think of that if the vehicles, all the vehicles on the road, if get stopped for a month, it will be the very clear sky that we can be able to see. And maybe many of you have experienced it during the COVID days when the normal traffic was at halt. We used to have the lesser temperatures, we used to have the clear skies, and the good clean environment we used to have. So pollution also, these vehicles are, which is specifically these oil-based and the gas-based vehicles are, who are a major pollutant category also. So whenever we are thinking of any of a new solutions, which is one, autonomous vehicle is one of them. Whenever we are thinking of any of a new solution, we shall be very careful about that what is the powertrain, what is the technologies, what are the vehicle types we should be using for the vehicles, so that it should not be very harsh to the environment. It should be easy to be adapted, and it should not create any kind of a harm to the mankind also. So these are the different of things that we are expecting from any of the vehicle technology and any of the energy sources which we are going to use. So this is the base, this is the reason why we are talking about the AGEVs. There is one more consideration that is related to the safety. Almost, like this is the data from 2014, now it has actually increased. There is approximately of a 4.9 lakh of accidents that happened. So approximately one accident every minute that has happened in 2014. And that led to 1.40 lakh of deaths. And injuries are, whether it is the severe or a normal, injuries were of a 4.63 lakh. So this is a huge number. This is the fatality rate is quite higher in India in the road accidents. We have the higher of population, and there is a different moods of the drivings are, and that leads to the higher number of accidents and the deaths on the roads. And the loss due to this accidents and the kind of deaths are approximately the 3% of the GDP. Again, on national highways, again there are the higher numbers. This is mostly due to the driver faults. 78.8% of the total accidents are been due to the faults of the driver, and approximately over 20% of the accidents that is due to the overloading or overcrowding of the vehicles. So if we have the technology which could use the lesser of pollutant, which will be lesser of a pollutant, which would be emitting less of a carbon dioxide. And if that vehicle technology anyhow can give the some level of autonomy that even the driver is at a fault, it will manage the vehicle, it will prevent the accidents. So definitely we will be accepting that. And that's why there is a significant demand going towards the autonomous vehicles. And in the autonomous vehicles also, the electric drivetrain is the now demand, because your electric drivetrain is going to use the battery sources as the energy, which is almost zero carbon emission. And with the help of the autonomy of the vehicle, we are getting the assistance and we are getting the full control of the vehicle also, which may lead to the control of the vehicle in case it is getting at a fault due to the driver. So those two things we can avoid, and that's why it is the choice now. We are a little behind in the adoption of the technology, though for the last 8-10 years we are now going very fast. But before of that, we used to develop the technology, but adoption was very less. But I'm giving you the data of the few of countries who have adopted the technology very faster in the autonomous domains. Autonomous vehicles are not of the new things. It has been on talk since last 1939 or 1940. So they have somehow accepted, like Japan, Netherlands, UK, USA, these countries, see their fatalities was in 1950 to 1960-70, there was at a peak in Japan, and after that there is a significant drop. Similarly in Netherlands also, similarly in USA, UK, everywhere there is a drop in the fatality rate, is because they have adopted the autonomy, a level of autonomy in their vehicles much earlier. It is assisted driving. It is not a fully autonomous, but it is assisted driving that they have adopted. Similar, but in case of India, if you see, it is continuously growing from 1970 to 80 to 90. This is the data from the Ministry of Road and Transport only. So till 2010-14, there was a higher increase in the numbers. And specifically, if you see the statements of our Road and Transport Minister, Mr. Nitin Gadkari, he was running a special drive for averting the road accidents. He has to specifically request to the people to avoid the road accidents, to drive safely. And there is a special drives. This is the one of the major concern for the Road and Transport Department in today's time, because this ratio is getting increased. So how we can do this? What are the solutions? One is about the energy. That's what I have talked. Another is related to the safety. So here the solutions are, one is about the acceptance of the electric drivetrain. That might be a battery electric, that will be a hybrid, where you are using the fuels, your diesel and petrol, along with the electric vehicles, along with the electric drivetrain, or it is the complete electric, like electric car or electric scooter or something, which is completely running on a battery only. Can anyone name here few electric cars? Your chat window. Few model names of electric cars. Company has electric car in India? Okay, few names have come. Seems Tata Harrier EV, good. Tesla. Tesla is not from India, Girish. I'm asking for the India only. Tata Nexon, Tata Punch EV, Tata Nexon EV. Yes, everyone has given Tata Nexon. Any other than Tata Nexon, which has been made in India? Ago also good. So Mahindra has any? XUV 700, that is on electric. Good. So companies are coming up with electric drivetrains. So that is a one solution towards the pollution or the energy. That's what I was talking about. I have talked about you two of the factors. One is about the loss of energy or the pollution, and second is about the assistance in the driving. So solution to the first, that is related to the energy, is the drivetrain. That is a all electric is the best one. If it is not all electric, maybe because in all the conditions, all electric is not a suitable one. Like if you are in a hilly region, there all electric will not be a suitable drivetrain because you won't be getting the enough torque. So that could be a problem. So there we have a fuel waste also. So they are the hybrid. And the answer to the safety part is the ADAS, the assisted driving, the advanced driving assistance systems, which will be, there will be the different levels of autonomy in the ADAS, from a no autonomy to a complete autonomy. There are the 6 levels are there. So these two things are there, which makes a combination of your autonomous electric ground vehicles. That's why we have kept it the autonomous ground electric vehicle as the stream, so that we will be talking about the autonomy, we will be talking about the electric drivetrain, and including both of it, it will make a miniature or a full-fledged vehicle. We can implement the autonomy in the normal fuel-based cars also. Like many of these cars, like your XUV 700, there is a diesel-based also. It also comes with ADAS. Your any of a car which is in the range of 5-7 lakhs, that starts with coming with the ADAS, which is giving you park assist feature, which is giving you front and rear views. It gives you the body electronics feature. It gives you to set the postures. So those kind of features are there in the fuel-based cars also, your diesel and petrol-based cars also. But that is not the target, because the future is of the electric, whether it is the battery-based or it is the green hydrogen-based or maybe some other energy sources. So that's why electric and the autonomy. So the ADAS, those two things is the considerable point, and where the scope is the growth. So what does make a vehicle autonomous? If it is just a driverless, can we say it an autonomous vehicle? If it is just a driverless, it can be a remote controlled also. Like the driver is, you have a vehicle, maybe an off-road vehicle, you have a remote control in your hand and you start controlling it through the remote, but that is not a autonomous. Only the driverless vehicles cannot be considered as an autonomous vehicle. The autonomous vehicle should have the 3 Ds that is necessary. It should have the detection, it should have the delivery, and it should be capable of the data gathering. So it is not a toy. It is autonomous, means full autonomy in itself. On its own, it can detect, it can deliver, and For detection and delivering, it will be gathering the data. So 3Ds is the necessary part. The detection is the surroundings and the current conditions. What is the what are the surroundings? What is the environmental surroundings? What are the vehicular surroundings? All these things are the necessary part for the detection. And which one is of our use? Like you are moving on road, there are the electric poles, there are the water pipelines, there are the red lights, that is of your use. So we need to detect and we need to reason that which one detection is of our use. Like I am detecting that a pedestrian is moving in front of my vehicle, then I have to stop the vehicle. If any car is coming in front, I have to take a corrective action for my vehicle. If red light is there, I need to stop at red light. So these are the reasoned detections. Means you are detecting, you are identifying that this detection is for our purpose or not, and then accordingly you take the actions. If it is an electric pole or if it is some building on the road, it is there. It is not for your purposes. You can keep on moving ahead accordingly as per your path. Then the data gathering. From the information search knowledge base for purposable actions, for the purpose actions, and what to do next. So we are keep gathering the data. As we are moving, we need to keep gathering the data. Like for an example, for the first time, once you have came to your college from your home, you came via maybe the taxi, maybe you came via bus, maybe you have come via your bike or any of a thing. The first time you were remembering that I have to go on this road 101 kilometer, then I have to take a right, then after going 500 meters, I need to take a left. Such kind of informations you were gathering while you were coming the college for the first time. Just remember in your first year or once for the admissions, once you have come to your college. So you were gathering those informations that how the routes are, from where I have to take left, from where I have to take right, in which lane I have to go, and at which place I have to park my vehicle in the college. Now, once you have gone next time, that information is there in your database, in your knowledge base, it is there. Now, automatically your vehicle will be through your mind controls, automatically your vehicle will start. It is not automatic, but yes, your mind starts giving the controls that now take left, now take right. And that is the information search we did from the knowledge base. For the first time, we created our knowledge base, and next time we are using those knowledge base and for the reaching to the college. Similar kind of a thing is there with the autonomy also. For the first time, it is going through the road. It will collect the information through the imaging cameras, through the sensors, through the lidars. By using all the means, it will collect the information and it will store in its local memory and in the cloud. So we will be talking in this internship. We will be talking about the cloud also, that how to store the data in the cloud, so that next time once we are moving across the same road, we will get the information from the cloud, and the driving commands would be generated from the cloud itself. We don't have to take the again do the information search until and unless there is no significant change has happened in the environment. So that data gathering, creation of the knowledge base, and using the same knowledge base for the next time, that is the part of the delivery and the learning. So these three things, delivery is related to the delivery of the commands for the next time driving, and this all is the part of a learning. So these 3Ds are necessary for any of a autonomous vehicle. It is not only just a driverless vehicle is an autonomous vehicle. So this is clear to everyone. Anyone is having a question here? I am giving a wait for 1 minute. If anyone is having a question till now, you can ask me. You can type your question here or you can take a water for 1 minute. It seems no question. So, with the help of these 3 Ds, the current approach is to have a fully autonomous vehicle, like a taxi, like cars, taxi-like cars, pods. You must have heard of these autonomous pods, where you just go and sit. It has a route fixed. It will keep going on the particular route that has been defined, and it can take you from one place to another. That is a pods. Then there is a autonomous in closed systems. Those are the monorails, like Mumbai has monorail, where it is moving completely on its own, like a metro also in Delhi. There is the automated metro systems are there. So there is no requirement of the driver, but it is in a closed loop. It is not like that it has to search its routes. Its route is already fixed, that the stations are fixed, where it has to stop, the positions, everything is fixed. But it is autonomous, that it is sensing all those points and the locations, and based on what it is taking the actions. So that is the autonomous monorails or the metros. That is again, but it is a closed system. And another is that is a common one we will be finding is the assistance systems, where with the help of the environment sensing, distance sensors, or ABS systems, the automated braking systems. So these are the 3 types of the current approaches. Fully autonomous, where it can search, it can take decisions, it can reason its own path, routes, everything on its own. The autonomy in a closed loop, like a rail systems, the metro rail systems or the monorail systems, and the common systems, which is assistance-based driving, where you have the ADAS with your vehicle and you have some level of autonomy. And this is how categorized in the 6 levels. First is the no automation at all. That is called as 0 level of automation, where it is a fully manual control you have to do. You don't have any of automation in your vehicle. You just drive as per the regular driving patterns. Then it comes the driver assistance. The vehicle can assist the driver with a single automated, only one automation system, like a cruise control. You have fixed a speed and the vehicle will be keep moving on that fixed speed. That is a cruise control. And there is an adaptive cruise control, where vehicle on its own can increase or decrease the speed to keep a safe distance from the front vehicle. Like you are moving on a road and there is a front vehicle going on. Now, if that vehicle is going on at a particular X speed and you are also at the same, it is a chance that you may hit the vehicle. Or if you are increasing the speed, it may be a chance that you may hit the vehicle, because if the front vehicle is not changing its speed. So that's why the adaptive cruise control does what? Based on the distance of the vehicle, it keeps changing the speed of the vehicle on its own, and accordingly it gives you the safer distance from the front vehicle. That's what the driver assistance feature. Then there is a partial automation, where the ADAS comes. From the 0 level and 1 level, it is not considered as a ADAS. From the 2nd level, it is considered as a ADAS. That is, the vehicle can perform both steering and power control feature both. In the driver assistance, what happens? That in the adaptive cruise control, you are getting the warnings or the signals that you are reaching near to the front vehicle, or you are going to get an accident, those kind of things. So driver accordingly takes the action. Whereas if it is a ADAS based, then the steering of the vehicle is also being controlled by the autonomy itself. So it starts controlling the motor and the steering and all the things. That is the 3rd level. That is the partial level. Then it is the conditional automation, where the vehicle can do the driving tasks also. Driver is necessary, but majority of the driving tasks are performed by the vehicle on its own. That is with the environmental detection. Like if there is in BMW earlier, it used to be the parking assistance. So the driver is sitting, but the vehicle can itself search for the parking space and it can park it on its own. The driver does not have to do anything. Once it has to just enable the park assist feature. Now in many of cars, it has started coming. Similarly, the control of the heating or ventilation systems, if it can automatically control the heating and the the conditioning systems of your air conditioning device accordingly as per the outside temperature. Those kind of features are there in the ADAS. Then maybe the infotainment system control. All these are the features that the conditional automation it comes, and driver is sitting driving the vehicle, but he is getting more of an assistance through the electronic control systems or the sensors around of it. Then it comes the ADAS with the environmental detection and the monitoring both. It is the environmental detection only. The actions the driver is taking, he has to enable those features. Here, it is the monitoring is also been done. Like whatever the detections are being done, are the tasks being performed as per those detections or not? That is considered under the high level of automation. Here also the driver remains seating, but here the action of the drivers are very less. He has to just keep track that whether the vehicle is moving properly or not. Like a normal metro systems, where the driver is there in the cabin, but he just takes care that everything is functioning properly. Rest of the things are being controlled by the automated system of the metro itself. And then there is a full level of autonomous or high automation also you can think of in the aircrafts, where the assisted landing features or automated flight attendance systems, those are there, which like the pilot has done the job of the flight lifting, and after of it leaves the aircraft on the assistance system. The assistance system of the aircraft automatically decides that at what height, at what pressure it has to fly the aircraft, and once it is the landing, at that time the pilot takes the control on its own. But for throughout all the time, the driver, the pilot is necessary to be in the cabin so that he can ensure that everything is functioning properly. But in the morning, we had talked about the UAVs, where no one is inside. The aircraft on its own has to take the decisions, do the aerial navigation, do the actions or the payloads, what is connected with it. It has to do all the actions on its own. Or maybe, so that is the full automation in the aerial vehicles. Similarly, the full automation in the passenger cars also possible, where like a Tesla autopilot, where even the driver is no longer necessary. The vehicle will perform all the driving tasks without overriding any of a thing. All the detections, all the kind of reasoning, all the kind of control of the vehicle, all the kind of monitoring of the actions that has been performed, everything is autonomous. So that is the full autonomy. That's what we are. We are generally in the range of a level 3 and level 2. Here it is the level 3 and level 4, the partial automation and conditional automation phase. The normal cars which are coming, they are with the partial automation and conditional automation phase. Now this is an attempt to go towards the high automation and full automation. That's what the target for these learnings are. And there is the future in next 5 to 10 years. There is the future for the implementations of these high automations and the full automations to implement. Already the much of work has already been done till the conditional automation levels, the partial and the conditional automation levels. So we have to always work towards the full autonomy, and that's what should be your target also. So the full autonomous vehicle, we can say it is the automotive which employs the driver assistance technologies to remove the need of a human operator for the driving related activities. That is a full autonomous vehicle. And cars are there, even two-wheelers are there. How many of you know about Ola Solo? Anyone have heard of Ola Solo? Just sharing. Okay. So what level of autonomy Ola Solo has? Yeah, sorry. So this is the first autonomous electric scooter. Can anyone tell what is the level of the video you have seen? What is the level of autonomy it had? You can also see this video. It is available on YouTube. You can go to YouTube and search Ola Solo. You will get many of videos. What is the level of autonomy have you seen in this video? recently just talked about the autonomous levels, level 0 to level 5. So what is the level of autonomy which you have seen right now in this electric scooter? Am I not audible? Am I audible to everyone? This is saying I'm not audible. Level 0, high level autonomy. What is the level number, Ilian? Just given the numbers, level 0, level 1, level 2. Level 0, level 5, okay, Ashita, it is good. What is the meaning of level 0, Girish? You are mentioning level 0. What grounds it is level 0? Fully manually. Go through the video. Fully autonomous. So this was the one thing. So what are the different problems are there related to the autonomous or related to the vehicle is we have what we have gathered the information. The road safety is one of the prime concern because of the low attention of the drivers. There is a difficulty in understanding the road danger conditions many of time, like if there is no adequate light, you won't be able to judge that what is the depth of the pothole or is there any pothole ahead, or if the road is not proper, you maybe not be able to judge that how long the road is in a broken condition, or it is just a shadow, or it is just a pothole. So if the lights are not adequate, so there are the different conditions which may or may not be understood by a normal road driver, and that may lead to the difficulty in understanding of the road danger conditions, and that's why there is a requirement of the autonomous cars. Then there is a need for the driving for everyone. Even if you don't know how to drive, good, but you have to travel from one place to another. So there is a requirement of the autonomous vehicles are, and two-wheelers, three-wheelers, four-wheelers, all category. There is a requirement for the self-intervention and the corrective actions. If the driving pattern is going bad, the vehicle should itself take the self-intervention and the corrective actions. And high fatality and the mortality rates in the road accidents are one of the major reasons to go towards the autonomy. And to provide this autonomy, there are the things which is available with us. So it is the sensors are the first thing which will figure out the obstacles around the vehicle. The navigation is the second thing. From one point to another, you have to go. So you need to navigate. Even if you don't know the routes, the vehicle itself should be able to navigate based on the map designs. Then motion planning. Any of obstacle is there, like in the scooter, that video you have also heard of maybe, that with every of a hit of these roadblocks, the Ola scooter is getting smarter. It means every of a time the vehicle is moving across the road, it is learning that what the obstacles are there in front. And that's how, based on that, it is updating its database. So the next time once it is moving through that, it will take the corrective actions beforehand. Like any of a speed breaker is there. If you see any of a speed breaker, what you do? You just lower your speed before of that only, so that you can easily pass that speed breaker. So being the same thing in the autonomous vehicle also, once it has hit first time the speed breaker, maybe the balancing has gone out. But next time, once the vehicle will pass through the same speed breaker, it has in its own memory that there is a speed breaker, and it will control its speed before hitting the speed breaker itself. And this is not in the local memory. All these data has to be a part of a cloud application. It might be a local cloud, it might be a global cloud, depending on the design, depending on how many vehicles are moving by autonomy, and what are the critical conditions you are going to store. Based on that, we do the motion planning for the traffic condition storage, and that's how the any of a rule for the drive is designed. And getting the vehicle itself to move everything everywhere, that is the major requirement is. That is the major demand from any of the vehicle is. So we can expect from the autonomous car to first thing to have an adaptive cruise control. The driver should automatically adjust the speed of your car in order to maintain a safe distance to a vehicle in front. Normally this happens that whenever you are driving, you always keep a safe distance from the vehicles which is moving in front of you. Similarly, the adaptive cruise control should also be, once you have enabled the adaptive cruise control, the vehicle should be able to keep it at a safe distance. We will be going in detail of each and everything. I'm just giving you a glimpse of the things what is required, what are the things that is related to the autonomous cars or the autonomous electric vehicles. In each of the topic, we will be going in detail that how do we do that, and these are the part of the hardware implementations also. So this is a one, adaptive cruise control. Second is the traffic alerts. So we are moving across the traffics. There is a rear cross traffics are like here in this image. If you can see, the vehicle is moving across the road. Here, this vehicle. Now these are the vehicles parked. This vehicle has to is going back maybe somewhere. It has to come this way, or it has to come this way and go this way. So this vehicle has to communicate to the all other vehicles that at what distance the other vehicles are, so that it can avoid any of a potential collision. So it alerts the driver with the audible and the visual indicators that this is the safe distance for the vehicle to move or not. So this is the RCTA, that is the rear cross traffic alert. This uses the radar sensors to detect the incoming vehicle to the left or right when a car is reversed. So like you are reversing the car, this car is moving ahead. So this gets the information, this car gets the information that there is a rear car moving at a distance, and whether it is the 1 meter, 2 meter, to 9 meter, 10 meter, whatever the safe distance that is there for the car, whether that safe distance is being maintained or not, that's what also it has to keep in the information. Then lane departure systems. Always there is a lane driving is preferred. Everywhere there is a lane made on the road, and if we are driving in our lane, only then it is considered as a safe driving. If you are not in your lane, you are having a zigzag driving, that leads to the accidents and the jam everywhere on the roads. So camera monitor lanes, cameras are there which monitor lane markings. If the vehicle starts to leave the marked lane while the turning signal is off, the system alerts the driver. Like if you are going in your lane and you need to change your lane, like you want to go from here to here, you need to give the indicators for that I am turning left or I am turning right. But if your indicators are not on and then you are changing the lane, that will be a problem. That will be a cause of a accident for the other driver. So that's why it will alert the driver. So a lane departure system will be an audible alert or a dashboard indicator, or maybe at a seat or the steering wheel also. The vibrations, that's what we do. If there is a lane departure that started happening, we do a vibration also. So these are the expectations related to the for the safe driving. That's what is expected in the autonomous cars. And these all things we can implement it as a project also. We can design a miniature autonomous car, and we can make the yesterday I have shown you the video. It has those everything. It was going through the lanes. It was detecting the red lights. Thereafter, it was detecting the obstacles. Similar kind of things. That's what is implemented at different levels in the vehicles, so that your autonomy to the vehicle can be provided. So these are the general expectations in the level of autonomy with any of autonomous cars we have. Once we are doing this, there are the certain of issues. Issues are related to the technical issues, because this is a nascent industry. It is not mature. So still lots of R&D is happening. Like in the UAV also, the R&Ds are happening. Similarly, in the AGEVs also, lots of R&Ds are happening related to the sensors. There is a requirement of a good efficient sensors which can easily detect and understand the environment. Like the Ola scooter you have seen, they have developed a special chip. There is a huge demand for the VLSI engineers also in this domain, because we need to integrate the automotive control systems, the IoT based systems, and the artificial intelligence together in a single chip, because we have to keep the sizes small also. We can't use multiple of the chips. So that's why. And then there is a requirement of the design of good sensors and the transducer systems to understand the environment, which will be easily useful for the vehicles. Then the navigation, know its current position and where it wants to go. Based on that, the motion planning will happen, navigation through the traffic. So accurate navigation through the traffic, that is again a current issue. And operate the correct and needed features. When what feature is required, it should be able to do that only. And that's why all these things are still under test. A fully autonomous car still has not been put into the practices. All these things, all the projects which you are seeing, whether it is your Google's Waymo or it is the Tesla Autopilot or any other. Uber is also now has launched its own autopilot car. So all these are under the test, under the prototyping, and it is going for long, because it has to collect the data. Once it is going into any of a new city, it has to collect the data for that particular city, so that it can be fed into the system, and then a proper motion planning could be designed. There is a behavioral issues also, like whether the people are taking this or understanding the vehicles or not. That's what is again a common issues. So trust of the vehicles, getting the public on road, getting the people to go into it. These are the again social issues that is being faced. Then it is the liabilities issues, like if any accident happens, who will be liable for this? If any damage is happened by the car, who will be liable for the damages? So all these things are the concerns for the autonomous cars, for the people to take into consideration, and that's why there is a researches are going on for this. Then it is the job loss. definitely it is going to take the job of the drivers. And once the whole autonomy will come, it is going to take the job of the drivers. It will lead to the increment of the unemployment. So these are the reasons, the social concerns related to the autonomous cars, and it is getting solved one by one. So control, navigation, sensory informations, these are the things. For control, there is a drive-by-wire conditions are. So like you are having the wired communication and wireless communication. So if you are not sure that whether your wireless communication is secure or not, you can have a drive-by-wire feature also, where you can send the messages from your sensors to the onboard computer through the wire. That is still there in many of cars. The sensors are there, and those sensors like the radar sensors, LiDAR sensors, the heating, ventilation sensors, all these sensors are there, and all of these sensors are sending the data to the main ECU through the means of the wires. What is that communication protocol is? Can anyone tell me over here? What is the communication protocol in these vehicles are being used? Anyone know about the communication protocols being used in the vehicles for communication between the different modules of the car, or like from the one part of the car to the ECU? Communication protocol have you heard of, which has been used in car, that is wire based? Normally, like even a smaller car, like I'm talking about Maruti Alto or something like this, they also have around 38, 39 microcontrollers inside them. All of them, like your door control systems, your seat positioning system, your infotainment system, your window up and down system, then the indicator for the fuels, all these are separately working. All of the places the microcontrollers are there, and all of them need to communicate to the ECU. So that ECU is taking care of all the controls. So that communication happens over the wire. What is that communication protocol is called? How many of you heard about CAN? Anyone tell me? You know anyone CAN? What is CAN? CAN is the controller area network. That's what we call. So whenever multiple microcontrollers are communicating over the wire through each other, it is being controlled via the controller area network protocol. It is a two-wire protocol. T plus T minus is there. And that's how the communication travels from one device to another. It is more used in the vehicle domain, but now it is getting into the other domains also. That is a two-wire protocol. And one-wire protocol is the ISO SPI. So this is CAN is a two-wire, and ISO SPI is a one-wire protocol that has been used nowadays in the different vehicles. ISO, it is not from SPI. Isolated serial peripheral interface. That's what is being used. So you remember these are the terms which is a very common for you if you are in the automotive domain. So controls are being provided through the CAN or the SPI protocols, where sensor is when the sensor is triggered or pressed, it sends message to the car to perform the actions. It replaces the human driver. It activates the sensors and servo motors for the each gear. That's what is again, because we can get the control of the each of the wheels separately. Large servo motor will drive for the steerings. That's what is also required. Then we have the GPS based systems. So we need to activate the GPS also in our autonomous cars. There are the variety of the GPS systems are available. Those GPSs are two types. One, the GPS systems will be a combination of two things. One is the satellite coordinates. So you should be getting the what? Latitude, longitude, and the altitude at what you are driving. You can also get the speed. So this will be giving you the GPS systems. And then we have the roadside database that is called as the V2X communication. So what things are? GPS can give you the coordinates, but it won't tell you that if you are driving on the road, on the left hand side, there is some, after going from the red light, 100 meters ahead, there is a pothole, or maybe the road is blocked. So you need to take a U-turn. So those kind of things, the GPS does not tell. For that purposes, there is a roadside database is being utilized. That is called as a V2X communication. So this is the same thing in your Google Map will also been used. In your Google Map also, we have the GPS communications, and then we have the roadside database also, like the data that has been available from the other vehicles. Like many of the vehicles which is moving on the car, which is having the Google Map running on it, and what is the speed, what is the cruise that is moving the vehicle. Based on this, the Google Map decides that the road is blocked or not, or there is a huge heavy road traffic, how much time you will take from going one place to another. You are also getting the updates that how much time you will take for going from one place to another. All these are available through the roadside database only. If there is a huge high traffic, that traffic congestion is being seen, it will tell you automatically that the time will be higher. And if the traffic is free, you will get it a normal time based on the speed that it decides. So your speed is an input, the roadside data traffic is an input, the Google Map running in the other vehicles, that is also an input. Then previously what has happened on that road, like if there is a pothole or any kind of a block has been experienced, that is also an input. And then the vehicle can communicate with any other vehicle also. That is a V2V communication. That's what we can do in the autonomous car. So these are the features that is there in autonomous car related to the navigation. Then sensory. The more sensor we are going to attach, the more of a computing power it will require. And the more of a computing power is going to take the huge amount of a battery. So that's why always whenever we are implementing the things on the as autonomy, we have to be very considerate about the design of the battery systems, the sensors which we are using in the vehicle, and what are the computational powers we are going to use. So selection of the sensors and the computation platform for them, that is again also a very necessary part. We can't attach more of a processors. This is again an issue that remains that we will be addressing about the sensors in the future of our sessions. Then laser detections, camera, radar, all these are the things which we use. So which one will be best and which one will be used for our vehicle? That's what we need to see. There are the factors for the weather, dust, rain, fog, all these kind of the weather conditions are how you are going to save your vehicle from it, and how your vehicle is correctly identifying any of the obstacle. Will it be able to justify between the shadows and ditches? Like if the ditch is there, so it should be understood as a ditch only. It should not be a shadow. If the ditch is there, how the depth of the ditch is, that's what also needs to be understood. And at what speed the vehicle should be moving so that the data would be captured correctly and you will be moving properly. Then motion planning. The most challenging thing is the motion planning, because you have to avoid the collision at any of a time. And for that, we have this adaptive cruise control systems. That is mostly affected by the sensors which we are using, the radar systems which we are using with our vehicle, and how much distance we are going to maintain with our radar. So that's what also the algorithm will be able to tell you, or can determine the movements between the, and for that we need to design the algorithms properly. That's what the roadmap leads to. So once we are moving from one point to another, that is like a point A to point Z. So how we are moving based on the a map which has been provided to us, or we have to configure the spaces. So this is an algorithm that we need to design, and it is commonly the configurable. So these are the, like this has to go, the vehicle has to go from this point A to point Z. Now these are the spaces. So these are the points we have determined that through this route the vehicle has to go. Now if I be taking those points, and these are the routes that it has traveled through. So there are the deviations into these routes. So that's what, how much deviation from at what place. It could have gone this way also, but it has seen that if there is a deviation, there is a shorter path might be, or might be there could be an obstacle. So that deviation, how will happen? That's what will be considered under the configure space algorithms, and the search algorithm. That's what we call search A to search G algorithms. These are called. So that's what is again the part of the learning on these autonomous cars. There are lots of challenges are happening. We are talking about the autonomous cars, and there are lots of challenges are happening. You also can later on also, if you design something, you can also take the challenge. Like this, there is one challenge from the DARPA, Defense Advanced Research Project Agency, and every year almost they are doing the DARPA challenges related to the autonomous vehicle. Maybe some mountain terrain, maybe on the deserts, maybe on normal road, maybe in urban traffic, everywhere. And they are giving the different challenges like collision avoidance, orbit traffic signs. There's another challenge is there is a one 2005 was the Stanley was the DARPA challenge winner. That was the Volkswagen modified car with the onboard computers on it. So there are the different. It has the lidars, 5 lidar lasers, and 24 gigahertz radar was there, camera was there. So these are the features that was there in that car. Making a fully autonomous definitely needs a different kind of a sensors onto it, and it has to detect and range the terrain and the driving conditions together. It has the built-in path analysis that is called as a RDDF. Database of path courses are there, and vehicle predominantly followed the RDDF data. So it has the previously fed, this Stanley has been previously fed the route traffic data, and it has moved on its own through that. These red spots which you are seeing, these are being determined as an obstacle. So it has previously fed the data and it has gone on that particular route only. It used to detect the obstacle with the help of the machine learning approaches. The accuracy value of data is based on how humans perform, and it slows down when a path cannot be found quickly. And grid of either occupied, free, or unknown spots also it was able to take the decisions. So it was able to traverse through the obstacles, traverse through the paths it has been decided for them, and the terrain which has been decided for it. Currently, so this was the one example I have given you. You can find more the research challenges which is happening related to the autonomous vehicles. The current developments are like few of companies like Google, the Google project, Google car, almost all of you must have heard of. So that is now Waymo. So Waymo is a company which is now specialized in self-driving technology, which is originally part of a Google. It has been separate now under Alphabet. Google is a search engine now. Alphabet is the parent company. So Waymo has been made under Alphabet, which is basically the Google car. It aims to create autonomous vehicles using advanced sensors and artificial intelligence along with it. Then we have the Tesla autopilot. That is again where the driver will be sitting, and so it has the cruise control features. It has the ultrasonic sensors long-range ultrasonic sensors to detect the objects that are up to 5 meters. So even another car is at a 5 meters of a distance, it will be able to sense it. The radars are there, which bounce back of nearby objects, helping the car to build a picture of its surrounding. So a visual image it can create, the radars can create based on the signals that it is being emitted. It can adjust the autopilot, so it can adjust the steering speeds and enable the driver to manually adjust the distance between the model, and there are the 2-3 models are there. It has an electrical braking system, so it is working on the electric drivetrain, and it has forward-facing camera for the vision computing. So any of a camera-based applications also it can do. So these are the different of the features this autopilot has. So there is a huge of opportunity in this domain. It is not only globally, but in the APAC region also, everywhere. There is a huge surge in the investments, in the technology, in the R&D that is going on towards the level 5 and level 6 autonomy of the vehicles. And that's why there is a good chance for the engineers to now enter into it. 5 years back, the engineers who were knowing even little bit of a EV got a good of a chance, and now they are at a good of a position. Similarly, the chance is now that if you are knowing the electric drivetrains and the autonomy, and the required skill sets are not much different. It is the AI that's what we need to implement, the machine learning we need to implement, the IoT clouds we need to implement, automotive embedded we need to implement. So these are the different technologies which we need to implement, and that's what it will be a good foundation for entering into the autonomous vehicle domain. All these things that we are taking here in this internship for your learning also, and that's what will be the continued as a project also. So that's it related to the introductions to the domain of the autonomous vehicles. Today we had the introduction for the UAVs. Now it was the introduction for the autonomous ground vehicles also. Tomorrow there will be the specialized technology sessions on both of them. Tomorrow we will be talking about the battery technology basically, because energy is the source which is driving all the things. So first we will talk about the battery technology first for the UAVs and for the AGEVs. For both of them, it is the lithium-ion battery technology is being used. So morning 10 o'clock we will have a common class, and evening at 3 p.m. you will have the Python and machine learning related sessions to start. So till tomorrow it is the common session, and then we will have the separate session on the drivetrains and depending on the requirements. So this was the delivery today related to it. Hope you would have understood. Any of your questions, if anyone is having, please ask me. 5 minutes I'm available. You can ask me any of a question you have related to the session, or any other doubt you have, you can ask me. Attendance to all the sessions are necessary, and evaluations are also. From tomorrow onwards, you will have the evaluations also. Till today, it is the introductory sessions, and the recordings and the learning materials will be uploaded on your LMS separately. From tomorrow onwards, it will be the evaluations and everything will be as per the standard. Any of the participants who have not registered yet, who is present in the session or not have made the payments, are requested to complete their things, so that from tomorrow onwards, it will be the sessions will be only for the registered candidates. Till today, it was the open session. From tomorrow onwards, it will be the closed session only for the registered students only. And that's all. This is the and then one more thing. This is this internship is integrated with your project, is the mandatory from your department. So ask your friends also to join, because if the sessions will move ahead, then we won't be taking the students from the back batches. So if they are joined in continuation, it is okay. After say moving the session, next 2-3 sessions if move, and then if anyone comes for the joining, it won't be possible. Questions, guys? You can ask me, or you can raise your hands also if you have to ask anything. After the session, everyone keep filling the attendance and the feedback form also, because that's what we are using for the capturing of your attendance. %5 attendance is necessary in the internship, in online and offline both. Okay, no questions. So which was the vehicle name which won the DARPA challenge in 2005? What was the name of vehicle which won the DARPA challenge? Okay, good, Stanley. Good. Okay, so no any questions, then I'll be closing the session. You can ask me later also on the LMS. Thank you for being here.